Hello, everyone. I know it's 6 p.m. Everyone got tired, and but no worries. I'll try my best to, whosoever is here, and we have, it's being recorded. So, show of hands, who here has shipped a library to Maven Central? Okay, this one. A show of hands, who here has shipped a library to Maven Central? Okay. Okay, so just you. Okay, keep your hands up if that library is currently running inside apps owned by other companies. No? Okay. Okay, so that's the third-party reality. You don't own the host process. Most of the libraries runs when you open sources external libraries. Even if you don't open sources, either runs inside your own company's apps or you distribute it to other apps. This talk is about what happens when you distribute it to other apps, which are not owned by your own company. It's another company's. So in third-party context, you don't own the host process. It runs inside a different app, which has its own release lifecycle. 6 weeks, if you're lucky. Your blast radius isn't just your users. It also includes their users, the another app users. Now, if we take that context, that there's a library which runs inside someone else's code base, and this is the release lifecycle. Now, that's library. Now, this talk is about SDK. Now, if we take that library and expand its product surface area to include things like auth, storage, analytics, AI, app lifecycle, and the whole partnership contract, that's the SDK. So 10 times the surface area of a library. 10 times to get things wrong. Your phone right now is running hundreds of pieces of infrastructure like this that as a user, we don't know. But here's one thing that makes this interesting. After 8 years, OWASP, the Open Worldwide Application Security Project, they made a new addition at the number 2 spot on their mobile top 10. And they explicitly called out third-party SDKs as the primary threat vector. And this isn't isolated. Even Sonatype, which is a platform to distribute all those open source libraries, they declared, they find out that more than 500,000 malicious packages were being distributed just last year alone. A number which is growing over 150% year over year. So my name is Raman, and I have spent last 14 years building this silent infrastructure in companies like Google, Snap, LinkedIn. I have seen what happens when SDKs are built right and what happens when they're built wrong. But first, let me tell you how I accidentally became a mobile developer, because honestly, I never planned for any of this. It just happened. So this is where I developed interest for computers. I call it Dad's Garage to sound a little cool, because most of the big tech companies, they started out of garage, and now they are billion-dollar companies. So my dad used to run a computer institute, and at that time, I used to play with floppy disk, that ball mice. Fast forward to 2012, I got my first job at Samsung Research India, and day one, they lined us up for project assignments. And the team lead called, hey, you Android. And that's where it all started. I started learning Android at Samsung at my first job. I'm learning, I'm building. And then in 2015, I came to US for my master's. My major project was on Android operating system. 2017, I got my first job in US. It was a startup. and I worked on their peer-to-peer mesh networking SDK. 2018, Google hired me to work on their Firebase Android SDK. Then Snap, again, building Android SDK. Then LinkedIn in 2022 hired me to build their on-device AI infrastructure. And I'm again building Android SDK. But what I want to tell here is, you know that random assignment at Samsung where they called me, hey, you Android? Sometimes the best career moves are the ones that you don't plan. And that it happened to be my best career move. At that time, I didn't have any knowledge of picking Android. And since then, I've been working on Android. So I'm just very passionate about it. Just want to share that story, how I came here. Now, I know some of you might be wondering, like, what even is an SDK? And why should I care? So very simple. SDK stands for Software Developer Kit. It's a toolbox of code and libraries that developers, it could be your own company developers, different team, it could be partner app, developer integrate to build features into their application without reinventing the wheel. But wait, there's some kind of confusion. I want to make it clear. So did everyone understood what's the difference between SDK and a library? Anyone can tell? Okay. Yes.
SDK is a lot wider because it
Lot.
contains libraries, it contains patterns, practices,
Yeah. Yes.
the user ecosystem around.
Yes. Yeah. You hit the nail. So yes. So for others, just trying to make it more simple to understand, I'll try to explain with the toolbox analogy. A library is you can call it as a single tool that does one thing well. For example, hammer. You grab it when you want to hammer nails, done. For example, like in mobile world, we have, even I think Java also uses Dagger. So we have Dagger for dependency injection. We have Glide for loading images. We have Retrofit for REST API calls. So they do one thing really well. SDK, on the other hand, is the entire toolbox that you use to build something big. For example, your home renovation kit. It has all the tools. It has hammer, nails, drill, saw, measuring tape. It has instructions. It has safety gears, all designed to work together. And that's important distinction. SDK is not a bunch of libraries packaged together in a single POM file. That's not an SDK. SDK is a set of tools which are designed to work together. And that distinction is important. It is designed to work together. For example, we have a Stripe SDK, which offers an easy way to add payment flow to your application. We have Firebase SDK, which offers things like authentication, analytics, storage, crash reporting, all as a set of tools, all designed to work together. And we have, let's say, Facebook Audience Network SDK that publishers use to monetize their apps. But before we get into the good things, there's one thing that keeps SDK developers up at night. What's that one thing? When you ship SDK code, it runs on devices you'll never see. And what I mean by that is you can't push a fix. You can't push a hotfix. You don't own the host process. You are dependent on partners' lifecycle. 6 weeks if you're lucky. Sometimes it takes even more. You can't reproduce bugs because you don't own the app. You don't know like where in the partner's app code your SDK is being run, and you'll never meet your users. It's not your users per se; it's their users, but it's indirectly your users too. But you don't have access to them. Building an SDK is like renting a room in a London flat share. You don't own the building. You have you're sharing room with other folks, and the landlord is your partner app. Can change the rules anytime. Make mess, make noise, leave bad memory, and you're out. And there are a queue of other SDKs waiting on the door to get in the next sprint. So that's the weight. That's the responsibility. Now, for apps, if there's an issue, these issues get fixed in an hours. User restart the app, life continues. But for SDKs, it's a little more nuanced. A few years ago, there was a popular SDK crash, which took down a lot of users' favorite apps. So these fixes does not happen like overnight in SDK. So SDK in the SDK, your fleet is not just your users. Your impact is much wider, and the consequences it has is like it has operational shutdown. But there is something interesting. There are patterns to make this manageable, design principles to protect you, architectural decisions that scale. I'm going to share 3 that matter most. So let me give you something actually useful. If I want one thing that that you should take home tonight, it's this slide. 3 core principles. Not 30, not 300, just 3. Believe me, I'm an engineer. We love complexity. I try to make it more complex, but every time I go back and check what worked, and it came down to these 3 things. Developer empathy, API promise, and making the right thing easy. Let's unwind all of them one by one. So developer empathy. This is the one that sounds most obvious, but is so easy to forget. And I'll tell you why. When you build that thing, you know how it worked. You know why that parameter is required. You know what that error means. It's obvious to other person. It's obvious to you, but it's not obvious to the other person integrating it. So what does developer empathy means? Developer empathy means make the behavior intuitive by default. Make the behavior predictable. No surprises, no magic. Now, I know we are developers, we like surprises, aha moments, hidden features, Easter eggs, whatever we want to call it. But if your code is running inside someone else's code base, being predictable and being empathetic is the key to win. Second is API promise. So here's a problem that I see most of the time. You expose OK HTTP types, return file objects, use media player. It works great until you need to change. Changing API breaks everyone who uses it. Because once you ship your API, that's a public contract. That's set in stone. Breaking changes are expensive in time, in trust, and in developer goodwill. But if you hide those types behind your own custom types, your own names, then you can change the implementation, optimize it, refactor it, or rewrite the whole thing in a different language. No one cares. So that's the API promise. Stable surface, but flexible internals. Now, we all have seen APIs like this. we want to upload a file, but the API says, here are the 8 parameters. Go figure it out. And nowhere in the documentation, someone mentioned why that timeout, or either that timeout is in seconds or milliseconds. You just have to guess it. Now look at this. Same capability, single line, works for 70% of the use cases, done. If you want more control, just provide overridden functionality. Let your users define custom chunk size or even bring their own networking stack. This is what I call progressive complexity. The idea is don't force your users to level 3 just to use basic features. All right, so we talked about the 3 principles. It's all great in theory, but I want to go more. I want to show what happens when we ignore these principles and what happens when we follow them. And I want to tell that with a story to make it interesting, hopefully. So this is a story about 2 apps. Meet Amplifier. It's a music platform for creators to publish and listeners to stream. 100 million monthly active users, massive audience. Their problem, their users are always hungry for fresh content. So they built an SDK. Their pitch to other apps, your users make great stuff. Let them publish directly to us and we'll handle the audience. Reasonable ask. Now meet MyBeats. You know that friend who makes incredible beats on the phone while riding the bus? Talented? Absolutely. Followers? Just 3. And 2 of them are their parents. MyBeats has 10 million creators in emerging markets, making music in bedroom, in commutes, over lunch breaks. But there's a problem. The user create the track, and then what? They send to friends, group chat. They need audience. They need amplifier. Amplifier has the audience. Perfect partnership, right? So let's see what happens. So MyBeats is ready. So MyBeats want that publish to amplifier button. So user create the track and they click on publish to amplifier and it's available to the entire audience. But let's make it a little bit more interesting, add more twist. So you like physics? Okay, many engineers do like physics. So what if we could peek into alternate realities? Same story, same characters. We have 2 apps, but one thing that changes everything, that decision, is how amplifier architects their SDK. In Universe 1, amplifier offers MegaBlob SDK. MegaBlob has a philosophy. Why choose which feature to integrate when you can integrate everything? Streaming engine, sure. Ad integration, of course. Blockchain, absolutely. Someone might need it someday. AI is 2026. Why it's not there already? MyBeats wants to upload a track. MegaBlob says, here's 8 megabytes. Welcome. The documentation, well, it exists somewhere probably. Good luck finding answers to your questions. In Universe 2, amplifier offers awesome SDK. Awesome is modular. Need to publish? Here's the publish module. 300 kilobytes. Done. Don't need streaming engine? Don't install it. Everything we talked about, those 3 principles, developer empathy, API promise, making right thing easy. Amplifier's awesome SDK actually does them. So let's expand these universes and see what happens when that same feature is being built in 2 different architectures. And let's unveil the story. I hope everyone is excited to see the story. Okay, so all right, Act 1. MyBeats want to integrate amplifiers partner SDK to let their users publish to Amplifier. Let's dive into parallel universe. Now, let's look at Mega Blob architecture. One giant module, 5 megabytes, API and implementation mixed together. You know that second principle? API is a promise. This code openly breaks that principle. 𝐒𝐵𝐸𝐴𝐶 just wants to upload a track, but they are forced to download all those cool libraries that Mega Blob has to offer. In Universe 2, Amplifier offers awesome SDK, and here that same feature is actually split into 2 modules. API module, which offers the API contracts, no dependencies, and implementation module, which has just the implementation for that feature. 𝐒𝐵𝐸𝐴𝐶 imports just the publish module. That's it. Nothing, no bloats. A few weeks later, 𝐒𝐵𝐸𝐴𝐶 came up with a request. And they said, we are migrating to �ＲxJava. So can we get observables instead of callbacks? Reasonable ask, right? Mega Blob decides to add �ＲxJava. But look what happened. They don't have an option to add �RxJava. They have to change their existing implementation. And what happened? It's a breaking change, version 2.0.0. On the other hand, awesome SDK actually created a new module, publish �ＲxJava feature. Under the hood, lightweight adapter, which routes calls to the existing implementation. Users who want to integrate �ＲxJava, they include the �ＲxJava feature module. Users who don't want it, they use the original feature. So the big takeaways from this Act 1 is, first, design features as modules. Give developers choice, not all or nothing. Second, isolate external dependencies. Don't force your runtime choices on developers. And third, provide idiomatic wrapper modules. What this means is build your basic features using the core APIs provided by your platform, where you don't have to use external dependencies, if possible, and provide idiomatic wrappers to meet developers where they are. It could be �ＲxJava, Kotlin coroutines, or whatever. That's modularity done right. But modularity is just one dimension. Let's go back to our parallel universe and explore another dimension of the same feature. So 𝐒𝐵𝐸𝐴𝐶 integrated amplifier SDK, users are uploading the tracks, it's working, until Universe 1 collapsed. And let's see how it collapsed. So here's how Mega Blob's sharing flow works. 𝐒𝐵𝐸𝐴𝐶 wants to publish a track. They deep link into Amplifier's publish screen. Amplifier wants to verify, is this actually from an approved partner? They use an API called pending intent.creator package. The idea is simple. It's stamped by the OS, so it provides creator identity. It does not use activity context, which means no memory leaks, and it provides a callback mechanism for success and failure. So it checkbox all the boxes. Sounds solid. You can't fake it, right? Seems like. So what went wrong? So one sunny day, 𝐒𝐵𝐸𝐴𝐶 posted a notification. Normal app behavior, nothing suspicious. But there was a malicious app who was watching. It had read notification permission, something that like millions of apps request. It grabbed 𝐒𝐵𝐸𝐴𝐶's notification and it deep linked into Amplifier's publish screen using that notification. Amplifier checked, Who sent this message? Pending intent says 𝐼'𝐵𝐴𝐻𝑒𝐻 approved. But it was not 𝐼'𝐵𝐴𝐻𝑒𝐻. It was the attacker. So pending intent says who created the intent, not who is using it right now. The attacker automates this. Thousands of phishing attacks, malware links, all stand by verified partner, 𝐼'𝐵𝐴𝐻𝑒𝐻. And thus Universe 1 collapsed. And this isn't just my opinion. Android official documentation says using pending intent to verify sender identity creates exploitation risk. It leads to vulnerabilities, authentication bypass, remote code execution. So what this suggests? This suggests to use binder.getCalling_UID, which is at OS level, kernel level, secure. So let's see how Universe 2 handle the same problem. Awesome SDK used bound service. Think of it like a secure tunnel between two apps. When 𝐼'𝐵𝐴𝐻 send a track, the OS stamps that message with the sender identity. Amplifier checks the stamp, 𝐼'𝐵𝐴𝐻, OK to proceed. Now what about the attacker? Well, attacker can try, but the bound service would stamp it with their attacker's identity, not with the 𝐼'𝐵𝐴𝐻 identity. The attacker can't fake it. And this wasn't a luck. Awesome SDK using bound service is not because their team is security wizards. They use it because they were modular. Modularity lead you to ask a question, which is, was the contract at the boundary? For publish, that contract was who is the caller and how do we know? And when you ask that questions, you'll eventually lead to a right solution. For Megablob, they didn't have the liberty to ask that question because for them, that publish code was living in a class with 10 other things. They didn't have the auth boundary. So they didn't have the liberty to ask that question. If you want a more formal proof of that, here's a paper that I published. It's on arXiv, so you can go and check it out there. So did you see how seemingly small thing, just sharing a file, could lead to a massive data breach? One architecture decision. That's all it took. That's why architecture matters. When you think modular, you design contracts and you validate them. But when you think just ship it, you grab the easiest tool without examining its guarantees. So architecture matters, not because it makes your code look pretty, but because when you get it right, when you get it wrong, actually, the innocent features like sharing a file could become attack vectors. And when you get it wrong, your users stay protected without even knowing that they are being protected. So all right, Act 1, modularity. Act 2, validating contracts. What's Act 3? What could be Act 3? It's 2026. What could be Act 3? Any guesses? AI. Okay, yeah, that's the common answer. Yeah, AI. You get it right. So every SDK will soon ship, ML models, recommendation, classification, personalization. But here's a question that nobody answering. Think about it. You ship a model. How do you update it? Updating a model means partner release cycle because you don't own the app. 6 weeks minimum. You want to A/B test. You want to know which model performed better. But you don't have consent to collect the data. You are third party. Partners' consent gives their app to authorize their analytics. It stays with them. It does not stay with you. So It's a hard problem. It's a hard problem. And the problem is clear. On-device AI experimentation within the SDK constraints. Because you don't own the process. You are separate. You are living in someone else's process. But here's that. So maybe that's part 2, because it would take another 30 minutes to go over this. But here's one thing that I want you to remember from today. Build modular. Validate contracts. Protect your users even from threats that they are not seeing right now. That's silent infrastructure done right. Thank you.